Media connectors and cabling. Everybody wants to be well connected. Doesn't matter if you're a striving, starving actor, or you want to be a professional musician, or somebody famous in the sports industry. Maybe you just want tickets to a sporting event. Maybe you want a burgeoning career as a network engineer. It always helps to be connected, to know the right people, to be into the right source. Well, I want to get you connected in this nugget to the different types of media connectors and the cabling standards that you're going to run into on your Network Plus exam. Of course, we can't cover all the connectors and cabling standards out there. There's just hundreds and hundreds of them, but we're going to touch on the major ones you need to know to be successful for your Network Plus exam. Sound good? All right, let's roll. In this nugget, we have three key knowledge objectives. First of all, we're going to look at a variety of cabling standards that you're demanded to know for the Network Plus exam. Then we'll look at various media types that are in use today, and then finally the connectors that kind of draw that media together with the network devices. Well, as I mentioned and as I promised, we're going to start out here with cable standards, and as you're going to see in this nugget, these cable standards and connectors are going to tie in real closely to the stuff we learned earlier in Network Topology Part 1 and Part 2. We're looking first here at some of the main Ethernet or 802.3 standard physical media, and 10BASE-T is pretty much, now in real life, let me just tell you this. If you were to go up to the internet and do a web search on Ethernet media, there is a bunch of different types of cables that are used, not just for other types, but also for Ethernet as well as many others. But we've used quite a few different types of older technologies or older cables for Ethernet. 10BASE-2, for example, comes to mind. But you don't need to worry about knowing about all of these different standards. I'm going to show you the ones that you're expected to know for the Network Plus exam. We're starting with 10BASE-T, which is just one of many physical media that's specified in the 802.3 standard Ethernet local area network. Now, the name 10BASE-T, as I alluded to, basically refers to several different aspects of the medium that we're dealing with. The 10 means you've got a bandwidth, a transmission speed of 10 megabit per second. Base, as we've alluded to, is baseband transmission, which I defined for you earlier. That means only one Ethernet signal is going to be present on the send and or receive pair of wires. In other words, no multiplexing like you get with a broadband transmission. And the T of 10BASE-T comes from twisted pair, which is the type of cable that we use with 10BASE-T Ethernet, twisted pair. And we'll look a little bit later at the two main types of twisted pair, UTP unshielded and STP shielded twisted pair. Also keep in mind that the maximum segment distance of your Ethernet based on the 802.3 standard when you're using 10BASE-T is 330 feet or 100 meters. And that has to come into play when you're designing your Ethernet LAN. That's 10BASE-T. Now, even though I spent quite a bit of time earlier in this nugget series in Network Topologies Part 2 talking about ring topologies, token ring, and FDDI, and things like that, Ethernet's really still king of the hill. It's the most widespread local area network technology. It's been that way for the past 15 years or so. Pretty much dominates all the other LAN standards. Well, 10BASE-FL is basically a part of the 10BASE-F series that typically defines fiber optic links in an Ethernet. And this is a fiber optic link between the concentrator, jot that down, the concentrator in that fiber optic network and an end user station, like a server or a workstation or even a router or a switch. So 10BASE-FL is an 802.3 standard that basically functions over fiber optic cable, and I'll go ahead and spell it ER, even though you'll see it spelled F-I-B-R-E, kind of the British method, or Brett Favre, the football player, never have understood how to pronounce his name. And it operates, of course, with the 10 here, it operates at 10 megabits per second over fiber optic cable. And it's a pretty well-known fiber standard for 802.3. Now what you're seeing happen more often is moving away from 10 meg per second for local area networking to try to get more bandwidth because of all of the distributed applications and all of the multimedia that we're using and video and audio streaming and the high-end computer-aided drafting and all these bandwidth-intensive applications. We need a bigger pipe. So let's move on up and talk about some of the standards that we can use that provide 100 megabit per second or fast Ethernet. 100 base T is actually kind of a collection of standards. Again, this falls under the 802.3 category. Actually, 100 base or 100 megabit transmission has been around for quite a while. So it's actually kind of an older standard, an older Ethernet standard. The official standard is 802.3U, again providing up to 100 megabit per second. And this is, again, fast Ethernet. So you can kind of equate fast Ethernet with 100 base T. Again, it's also collision detection, so it's CSMA-CD based. And really, you can use a wide variety of different cabling schemes with 100 base T. And these are 100 base TX, 100 base T4, and 100 base FX. Let's take a look at those. 100 base T standard cable. The three main cabling schemes that you'll use with 100 base T would be, first of all, the predominant one, the predominant fast Ethernet standard, which is 100 base TX. Here you've got two pairs of high quality twisted pair wires, and show up in here. And basically this gives you 100 megabit per second Ethernet, hence the 100, generally using category 5, either unshielded twisted pair cable or STP shielded twisted pair cable. Again, this is the predominant fast Ethernet. Then you've got 100 base T4, and this is going to be 4 pairs of not high quality, but just normal quality twisted pair wires, hence the 4. 4 pairs of a twisted pair wire. You won't see this as often. 100 base FX, however, is 100 megabit per second bandwidth, baseband transmission Ethernet over 2 multi-mode fiber optic cables. And we're going to look at some examples of fiber optic cable here in a second, and we'll look at multi-mode fiber specifically. So you do want to memorize these are the 3 main cable standards for the 100 base T family: 100 base TX, T4, and FX. And of course, there's a bunch of network engineers out there who work for large corporations. They're part of large enterprise networks, and they're saying, you know, fast Ethernet, it's so passé. We need to look at higher bandwidths, and we're looking at 1,000 base cable standards for Ethernet, and this is 1 gigabit per second or 1,000 megabits per second. So we'll just jot that down: 1,000 megabit per second or 1 gig, otherwise known as gigabit Ethernet. Gigabit Ethernet. There's 3 standards to be aware of for your exam. The first one is 1,000 base CX. Again, 1,000 megabit per second Ethernet over 2 pairs of what's called 150 STP, shielded twisted pair cable. I'll show you some cables here in a minute. Then next you've got 1,000 base SX. This is 1,000 megabit per second baseband transmission Ethernet over 2 multi-mode optical fibers, fiber optic cable that's using what's called shortwave laser. Laser. Whenever I hear that word, it always reminds me of Austin Powers. A laser. Then we've got 1,000 base LX, and this is also 1,000 megabit per second, or 1 gigabit Ethernet over 2 multi-mode or single-mode optical fiber cables using long wave laser fiber optics. So those are the three main types of standards that use gigabit or 1,000 megabit per second. You might make sure you want to memorize those. Hey, why stop now? We're on a roll. Let's get really obnoxious with 10 gigabit per second. 10 gigabit per second cable standards. You've got 3 of them here to look at. First of all, you've got 10, what's called 10 G-base, 10 G-base SR. And this is actually the 802.3AE standard. And your cable distances, it depends on the type of cable you're using. One type of fiber optic cable gives you up to 33 meters. A second type gives you up to 300 meters. So up to 300 meters with 10 G-base SR. And again, your transfer rate here is going to be 10 gigabit per second. Then you've got 10 G-base LR. 10 G-base LR, also a 10 gigabit per second transfer rate using fiber optic cable. I'll just put fiber, and distances up to, so I'll put equal to 10 kilometers. So up to 10 kilometers maximum distance. So you can see how this can be used in the backbone, let's say, for a large enterprise corporate campus, maybe a metropolitan area network, maybe something like a city government, something like that. Then you can step up to 10 G-base ER. 10 G-base ER, also 10 gigabit per second pipe, nice backbone core of a metropolitan area network, a regional network, 40 kilometers maximum cable length, also using fiber optic cable. These are emerging standards that you're seeing coming out that provide 10 gigabit per second bandwidths. Pretty awesome. Well, so far in this nugget and the nuggets before this, I've really mentioned quite a bit of different types of media and cabling. Let's see if we can kind of put a face on this and kind of maybe find a really good way to kind of match all this stuff up in our minds, the different cable types, the cable standards, with the actual media types that are used. And we're going to look at several here. We're going to look at Category 3, 5, 5E, and Category 6 cabling, talk about unshielded twisted pair and shielded twisted pair cabling. We'll look at coaxial cable, and we'll also talk about single mode fiber optic cable, and multi-mode fiber optic cable. Generally, I designated this by putting SM for single mode and MM for multi-mode. Let's take a look at these one at a time. Kind of at the bottom of the food chain here is Category 3 cable. This is a twisted pair cable. Typically, it rates at up to 100 megabit per second bandwidths, and this can also be represented as 16 megahertz. And Category 3 can be used for voice transmission. It can be used for data transmission up to 16 megahertz. Typically, you're going to see this with 4 UTP, or unshielded twisted pairs. 1, 2, 3, 4 twisted pairs. You'll find Category 3 cable used in ISDN. Oops, I need to spell that correctly. ISDN, which is kind of a digital standard that's been around since the 60s. You'll also see it used with T1. And again, I may mention some concepts here that aren't totally clear at this point, but throughout this entire Nugget series, this will all get defined quite well. Operating at T1 or 1.54 megabit per second. You may see it running in those particular situations. Also, Category 3 cable is used for several standards we've already talked about. It's used with 10 base T. You'll see Category 3 with 10 base T. You'll see it also with 100 base T4 Ethernet networks. Again, these are really kind of older standards now. You'll also see Category 3 cable, and here's a box of it, by the way. Generally comes in big rolls like this. You'll see it also used in token ring networks. I'll just put TR here, where you've got 4 megabit per second token rings. Also, most of your telephone systems, the plain old telephone system, going way back to the mid-90s, use Category 3 cable. You're not going to find Category 3 cable, so I'm going to put high-speed networks. That's high-speed, not high-speed. Okay, high-speed nets. Put a big circle here and go, not going to find it. You're not going to find Category 3 cable used in high-speed networking because it doesn't handle noise and interference very well. Unshielded twisted pair doesn't do well with noise. Let's move from Category 3 to a more prevalent standard that we're going to find now. That's Category 5. Category 5 cables, the one you're going to find used most often is patch cables that plug into your network interface card on your PC or your workstation, that plugs into ports on routers and switches. It's really the most popular cable used out there in network today. It also rates at 100 megabit per second, but it's 100 megabit per second at 100 megahertz. It's a high-grade Type 1 cable, handling frequencies of up to 100 megahertz. Currently, you're going to see Category 5 cable being unshielded twisted pair UTP 4 copper wires. So 4 pairs, unshielded twisted pair, used for high-speed communication. Again, up to 100 megabit per second, with distances up to, so distance for Category 5 cable, up to, so less than or equal to 100 meters. And again, this should look familiar to you. It's the most common cabling used. This is used in 10 base T, so I'm just going to put 10 BT here. Used in 10 base T. It's used in 100 base T4. It's also used with 100 base TX networks, fast Ethernet networks that we talked about earlier. You'll also see Category 5 cable used in FDDI implementations, also ATM communications as well, asynchronous transfer mode. It's been around since 1994, but in 1998 it was replaced with a newer standard called 5E. Let's talk about Category 5E cable. Category 5E cable is basically Category 5 cable, but it's been enhanced to have less noise in the cable, also enhanced to provide support for higher bandwidth. It's used, Category 5E cable can be used for 1,000 megabit per second Ethernet or gigabit Ethernet operating at 350 megahertz. You can use your Category 5E cable for your gigabit Ethernets, but it's still backward compatible. You can still use it in 10 base T, 100 base T4, 100 base TX fast Ethernet networks as well, and then you've already got it in place when you go to gigabit Ethernet. It can also be used with ATM networks supporting 155 megabit per second. Again, this new standard 5E came into being in 1998. Now, you might think the enhanced version of Category 5 is as good as it gets. Nope, we can move beyond that. We've also got Category 6. Let's check that out. Category 5 cable, Category 5E, 6 cable, all pretty much looks the same, except on the side here, on the actual cable itself, it'll designate whether it's Cat 5, 5E, or 6. Category 6 cable is one of the newest cables available to provide better performance. It's got a higher signal-to-noise ratio, overall better reliability for mission-critical applications that are running for local area networks and large bandwidth Ethernets. And it provides future enhancements and increases in data rates and better performance for applications. So that's final category 6 cable used for, again, 10 base T, fast Ethernet, gigabit Ethernet. Next, let's talk about twisted pair cabling, of which there's 2 major categories: STP shielded twisted pair and UTP unshielded twisted pair. We'll talk about UTP first, but overall, the category of twisted pair cables are named this way because you've got pairs of wires that are twisted around one another. Each pair is going to be made up of 2 insulated copper wires twisted together. These wire pairs are going to be twisted because you want to reduce crosstalk and any noise interference, for example, EMI, electromagnetic interference. Now, high-quality twisted pair cables typically are going to have about 1 to 3 twists per inch. As we saw earlier, twisted pair type cables are commonly used with Ethernet physical layers, 10 base T, 100 base TX, 100 base T2 as well. 100 base T4 is also going to use twisted pair cabling, and 1000 base or gigabit 1000 base T. Let's talk now specifically about unshielded twisted pair, or UTP. Well, unshielded twisted pair, or UTP, is just what the name described. It's twisted pair cable with no additional shielding on it. Basically, it's just these 4 pairs of twisted wires inside a common sheath. So UTP commonly includes 4 pairs of wires in a common sheath, even though all 4 pairs of those wires may not all be used. Now, typically, UTP cable is 100 ohm, category 3, category 4, category 5, 5E, 6, soon 7 category cables using the TIA EIA 568A standard. Don't need to really memorize that, but if you want to go do a Google search on that to get more information, feel free to do that. Now, 10 base T, 100 base TX, and 100 base T2 only use 2 of the wired pairs in the unshielded twisted pair. However, 100 base T4, hence the 4, and 1000 base T or gigabit Ethernet are going to use all 4 pairs of wires in that unshielded twisted pair cable. Now, when the term shielded twisted pair, STP, is used, it typically refers to the 150 ohm twisted pair cabling that was defined by the IBM cabling system to be used specifically with token ring networks. So it really isn't intended to be used with Ethernet, but the Ethernet standard does have some information on how you can actually adapt STP to be used with things like 10 base T, 100 base TX, and 100 base T2 by using these special impedance matching transformers. But STP is the twisted pair. These twisted pairs are wrapped individually in a foil shield, and then there's an additional outer braided wire on the cable. The goal, of course, of all of this is to minimize crosstalk even more than just twisting the wires and electromagnetic interference. Now, the original IBM cable types were of STP were type 1, type 2, type 6, type 8, and type 9. The newer STP cable types are STP-A. A means enhanced. It's STP-A cable 1A, 2A, 6A, and 9A that can support FDDI networks, FDDI topology, remember the double ring, up to 100 megahertz networking. If we think about STP cable, the type 1 cable is really that heavy black cable that's most often associated with the IBM cabling system and used in token ring networks. Now, shielded cabling, STP, may give us better behavior with regard to immunity and radiation, prevention of EMI and crosstalk, but it takes too much effort overall to provide this condition in terms of the money, in terms of the maintenance and regulatory monitoring. So really a good balanced unshielded twisted pair system, UTP, is going to provide excellent performance. It'll provide protection, and we'll be using UTP in most office and industrial environments. Now, coaxial cabling you're probably familiar with if you have a cable network or cable television at your home. This is what kind of the inside of a coaxial cable looks like, and it's really used by older Ethernets, 10BASE-2, which is called ThinNet, and you've also got 10BASE-5, which is ThickNet. Now, you don't really need to know these standards for the exam because they're so old, they're kind of outmoded, but 10BASE, obviously 10 megabit per second Ethernet networking. Older networks, where as I mentioned to you earlier in this series, it's a low-cost solution because you don't even need a hub. You can just kind of tap into the wire itself and create kind of a bus topology that's terminated on both sides, both ends of the cable. You do get better protection with coaxial because it has more shielding here than an unshielded twisted pair cable, but you got to be careful when you're laying this cable out, because if you bend it and you crimp it, you can actually damage it and make it unuseful or unusable. So that's older cabling, coaxial cabling. You don't see that used very much anymore in Ethernet deployments. And here's some more picture of coaxial cable. This is the kind you're probably used to seeing with entertainment components, and here's a roll of coaxial cable here as well. Single mode fiber, or SM or SMF, you can see here is a roll of it. It's called single mode because it only transmits light in one fundamental mode or one path in the wire. It has a very small core diameter, and it transmits light, all kinds of different information over longer distances than multi-mode fiber. So generally you're going to see single mode fiber used for long distances, not just between buildings in a campus or in a small metropolitan area network, but you'll see it over long distances. It supports extremely high bandwidths. That's single mode fiber. Multi-mode fiber, and here's a reel of it, is called multi-mode because the light travels in multiple modes or paths within the wire, multiple light streams. It has a larger center core than single-mode fiber, and you're going to see multi-mode fiber used for relatively short distances. You're going to see multi-mode fiber used very commonly for fast Ethernet LANs, gigabit Ethernet local area network, and campus networking. That's multi-mode fiber. Well, your media wouldn't be very useful, whether it's single-mode fiber, or multi-mode fiber, twisted pair cable, UTP or STP, or coaxial cable, or other types of media. Again, wouldn't be much use to you if you didn't have connectors on each end of the wire to connect these networking devices together. So we're going to look at a handful of different media connectors in this final part of this nugget. The ones are going to be covered on your Network Plus exam. Let's start with the most basic. RJ11 stands for Registered Jack Type 11. It's probably the most commonly used jack connector in the entire world. It's a global standard. This is the one that's used for your telephone. It's got 4 copper wires, and it uses a twisted pair cable used for phones, modems, and fax machines. Generally used with Category 3 cable, and historically RJ11 connectors and Category 3 cable was used for LAN networking, but really not anymore. What you're seeing now is the RJ45 standard connector. Let's take a look at that one. The RJ45 jack is the one we've been looking at in most of the diagrams previous to this. RJ45, Registered Jack 45, is really the standard, the industry standard that's used on your Ethernet LANs specifically with Category 5 cable, Category 5, and Category 6 cable. The jack is wider than RJ11, supports up to 8 wires all of the 8 wires may or may not be used. It just depends upon the implementation. Typically, you're going to use your RJ45 jack with a unshielded twisted pair cable, and RJ45 jacks can be used for telephony, with ISDN networking, 10 base T Ethernet, 100 base T4 Ethernet, and token ring. That's the RJ45 connector. F-type connectors are used on the ends of coaxial cables for a wide variety of different applications. You can also see little F-type adapters here. Probably familiar with these. You can see F-type cables that are male to male. They have like a little prong in them, male to female, but the connectors basically are used at the end of coaxial cables. That's what an F-type connector is. You need to be aware of the fact and be able to identify the 3 different common types of fiber connectors that are used for single-mode fiber and multi-mode fiber. What we see right here is the ST connector, and then under this is the SC connector. You can see the difference in how it looks. And the third emerging type of fiber connector is called MTRJ, and this is an MTRJ connector right there. As a matter of fact, it's an MTRJ that connects to an SC connector. So need to know these 3 different types and what they look like: ST, SC, and MTRJ for single-mode and multi-mode fiber implementations. Another newer connector that you'll see out there, which is really kind of more of an adapter type, is Fiber LC. And a Fiber LC is just an additional way to connect multi-mode and single-mode fiber in addition to SC, ST, and MTRJ connectors. You're going to see Fiber LC predominantly with multi-mode fiber implementations because Fiber LC is used for local connections. It's a LAN-based type of fiber connectivity. So when you see Fiber LC connectors, think of multi-mode fiber. Another connector that for some reason the Network Plus exam covers is the IEEE 1394 FireWire connector, because it can be used for certain network devices. Generally, it's used, though, to transfer data from peripherals to a workstation, a PC, or a server. You can see the FireWire jack here, and, of course, the port that a FireWire would plug into on either a PC or a particular peripheral. IEEE 1394 FireWire for high-speed data transfer. Finally, don't forget about the Universal Serial Bus Connector, or USB. A little bit older specification than the 1394 FireWire. It's also used to connect peripheral devices to PCs, workstations, and servers for high-speed data transfer. There's USB network interface cards out there, so it can also apply to your networking environment as well. You could have network interfaces that plug into a USB port on a PC, for example, to extend beyond the NIC card that comes on your motherboard, or to give you multiple network interface cards, or to multi-home that workstation or server. Universal Serial Bus, USB. Well, that's all the connectors to be aware of for your exam. Covered a lot of different things in this particular nugget. Again, a great suggestion is just to go down sometime to the largest computer retailer that you can find in your area. Just go down all through the aisles and look at the different types of cabling and connectors, and feel free to ask some questions while you're there, and make sure you're very familiar with the different types of media, the different types of cabling standards, and the connectors and how they're applied and used in local area networks. Fantastic job on this nugget. In this movie of the Network Plus series, we covered 3 main objectives. In media, connectors, and cabling, we looked first of all at the cabling standards, and we focused mainly on Ethernet cabling. Then we looked at several media types: twisted pair, a UTP and STP, coaxial cable, and different types of fiber optic cable. And then finally, different types of connectors to be aware of for your exam. I hope this CBT nugget's been informative for you. I want to thank you so much for viewing.